Welcome to Out of the Lab, a podcast interviewing entrepreneurs who've taken research out of the lab and built it into a company that's serving the world. These entrepreneurs are heroes, and the planet needs more of them. So tune in, learn from their successes and failures, and get inspired. Visit bountiful.org to join our community and realize your power to save the world. Hello and welcome to Out of the Lab. I'm your host, Max Finder, and we are here with Aaron Mandell. Thanks for joining us today, Aaron.
How's it going?
Going well. So I'm going to introduce you. Aaron has co-founded five. I'm reading your Crunchbase bio, so you can correct anything that is incorrect. But you've co-founded at least five companies at the nexus of energy and water, including Altarock, WaterFX, Oasys Water, Coskata, and Greatpoint. You also extracted Quidnet, I guess, which is an energy storage technology company. You're on the board. You also recently extracted Quaise, a deep drilling technology for geothermal from MIT. You ran Oasys Water. You have an environmental engineering degree, a bachelor's and master's from University of Vermont. And you have, he's advanced new products in fields such as solar-powered water treatment, desalination, enhanced geothermal, coal gasification, alternative chemicals. Does that about cover it? Is there anything I missed or anything I said incorrectly, Aaron?
No, that was actually pretty close. That's good. I think you captured it.
Crunchbase has their facts.
Actually, the only thing you left out is I did actually live in Israel for a little while. I did my master's research through Tel Aviv University before going back to UVM. So. Oh,
great. Okay, so I am calling from Tel Aviv. Aaron, you're in Florida, right?
Sarasota, Florida.
So thankfully Zoom allows us to connect. So the most interesting thing for me right now to ask, to just kind of kick things off, is this recent Quaise technology that you brought out of MIT. Can you tell us a little bit about the process that was undertaken in order to do that? It recently raised a $6 million seed round from the engine, and I think maybe collaborative fund, and just the story of how, like, the story that I read somewhere, I guess, was that you kind of introduced the founders to the inventor of this deep geothermal technology, and from there they built up the technology and eventually kind of extracted it and turned it into a real company. So I would love to hear more about that from you.
Yeah, Quaise is actually a really cool company. So the basic concept is around what's called directed energy drilling, which is an effort to switch off of mechanical drilling, which is currently used in the oil and gas space, to directed energy, which in theory will allow us to go much deeper, much hotter, much higher pressures than ever before. So the thesis is that if we're going to shift away from just extracting hydrocarbons like oil and gas out of the ground, and instead focus on mining heat at very high temperatures, we're going to need a new way to make it cost effective to drill very deep, very hot, very high pressure holes. So that was the basic thesis. And actually, Quaise was incubated inside Altarock, which is the company that I had started and was running at the time when we were working on this concept. So Altarock was a pioneer in some of the early technology for creating enhanced geothermal systems. Basically, Altarock focused on fracturing, creating enhanced geothermal reservoirs when you have very impermeable rock, and opening up the rock fractures so you can get the heat out. And so we did a lot of great work in partnership with DOE and others on that. We call it stimulation technology. And then got to the point where we realized that if geothermal was going to ever become prime time, we actually needed to focus on the drilling side of things as well, which is a huge portion of the cost and the ultimate economics of geothermal power. And so at the time, I connected with Paul Waskoff, who was a research scientist at MIT in the Plasma Science and Fusion Center. And basically, Paul had been working on this for many, many years. It's interesting. It was sort of stuck in the lab for a long, long time. But basically, Paul's kind of eureka moment was that he calls it energy trumps matter, which is that if you have the right energy source and you have enough energy, there's really no matter or no material that can stand in its way. And so a lot of the ideas that he came up with around using energy as a way to drill were born out of magnetic confinement for fusion, because you're dealing with such high temperatures. With fusion reactions, there's really no material in existence that can contain those temperatures, and so you use magnetic confinement. And so the device that's used to create that magnetic confinement is called a gyrotron. And so Paul's idea was to use a gyrotron, but instead create basically an energy beam using millimeter waves and aim it at rocks. So he created a very small setup in the lab and started doing some proof of concepts where he used a small 10 kilowatt gyrotron to destroy rocks, bore holes in rocks, melt it, evaporate it. And that was sort of the beginning of the concept. And so when I met him, he had some papers, he had some presentations, he had filed some intellectual property through MIT, but for the most part, there weren't a lot of people looking at it, and certainly wasn't any real commercialization effort. So I spent a good amount of time working with Paul, trying to figure out what would be the right path forward, the partners that we would want to have involved, and ultimately the team. And I ended up pitching it to MIT's venture capital group, which is called the Engine, and the partner that I pitched there, Carlos Araque, ended up being so excited about the technology that he left the Engine to become CEO at Quaise, and that was how we formed the basis of the company. And in addition to that, we had applied for a research grant from the ARPA-E organization. So that's how we got the early funding to do some of the basic testing, proof of concept, techno-economic work that formed the foundation for the business plan.
And so when you say it's stuck in the lab, like, and I have a sort of a corollary to this, is that was Paul inventing this just for the sake of inventing this, or was he chasing a solution to a problem in his mind?
No, I think Paul, like a lot of inventors, realized that he had a concept that really could unlock a solution to a very big problem. So I think, one of the traits that I've found in successful inventors that go on to do meaningful things is their ability to connect very big picture problems with very, very specific technical solutions. So it's sort of the ability to kind of, go through that full vertical from a really important important problem to solve all the way down to an extremely unique, specific technical solution. And that was certainly the case with Paul and many of the other founding scientists that I've worked with. So he had he had published a lot of papers on how millimeter wave directed energy drilling could be applied to deep geothermal. But it wasn't, it didn't really show up in any of the conferences or discussions or areas of investment. So it was just sort of overlooked, I guess.
And so that's what you mean by stuck in the lab. Like he had a bench scale type of experiment, and it was waiting for somebody like you to come around and pay attention to it, in theory.
Yeah, I think it was waiting for someone to put the pieces together to show that there really was a path to getting this to commercial. Because there's no question that it's a very early stage technology, and it's the type of technology that's not for the faint of heart, because it's it definitely does require a large amount of capital and a long period of time to scale something from, we're 10 kilowatts in the lab to, really we want to be up around over a megawatt for a commercial directed energy drilling rig. So, it's a pretty significant scale up.
Right. A
But
few orders of
from
magnitude.
few orders of magnitude, exactly. But from my perspective, all of the basic physics and the principles were sound. And I mean, there's a lot of things that were certainly unknown, a lot of modeling, systems engineering, and cost estimation that had to be done before you could determine whether it was really going to be viable. But the physics was sound. The concept was, I think, extremely compelling in terms of how efficient millimeter waves are in delivering energy from a gyrotron on the surface over very long distances into the ground. And so, yeah, I don't know. I think it's a great example of a technology that I felt like had all the attributes to be turned into a real company.
And so you're identifying not only there's a couple of things here, the commercialization pathways, right? Like that was a major thing for you, was to figure out the way that it could be commercialized, and also to figure out where the unknowns were and how you were going to prove them out. Correct? Could you speak a little bit
Yeah.
about that process?
Yeah. So what we started with was, which is often the case, just basic economics, maybe back of the napkin economics to determine what the advantage of this process would be over some of the other alternative drilling technologies out there, because there are some other approaches to drilling with lasers, drilling with plasma, drilling with water jets, water hammers. So there's other things out there, but after doing that and talking to some experts, I became pretty convinced that millimeter waves had a very unique combination of great efficiency, the right power level, and probably actually maybe most importantly is that gyrotrons are a commercial piece of equipment. Even though they're not used in enormous quantities, they actually exist at megawatt levels for various medical applications and certainly for a lot of fusion science. So it was a piece of equipment that was out there, and at least when we're ready, we could buy one from a company in the U.S. that makes them. So that was a big component, because we obviously need to scale the system, and we don't want to spend 15 years just trying to manufacture a gyrotron.
Right.
So that to me was a big component. The other big component was the fact that you could transmit millimeter wave energy over very long distances using a relatively standard, it's basically like a corrugated metal pipe. So using something that would begin to resemble a drilling rig, and a steel pipe to deliver the energy over long distances, you could begin to kind of see how that could be turned into a commercial drilling rig. And so from there, we pulled together some key partnerships. So there was another sort of private R&D group that was doing a lot of the development. And we also partnered with the Air Force Research Lab in Albuquerque, New Mexico, that has several gyrotrons. They actually have a 100 kilowatt gyrotron that's mounted to a Humvee, because the military uses millimeter waves as a technique for moving crowds back from very long distances. So from a couple of miles away, you can actually feel the heat from the gyrotron without getting close. And so we worked with them to propose a research and development plan to ARPA, and ended up getting an award from ARPA to do the early research and development. And I think that was probably the primary catalyst for getting the company launched, because we had non-dilutive funding that would fund some of the basic research and basic science, and we could match that with venture capital funding to do more of the commercial work and put the team together.
So, and this seems like, I know this is not, this ARPA-E grant was not the first government non-dilutive funding that you have unlocked, correct? Like, this is not your first rodeo with that, right?
No, and I would say very often getting some early non-dilutive funding is a way to really catalyze a commercial effort. So, like for instance, Quaise, which is another company that I had started. I'm sorry, not Quaise, Quidnet. It's too many
Too many
Qs.
cues.
All
Yeah.
my companies, by the way, they're all named after places on Nantucket Island because that's where I grew up spending my summers, and it was the only way I could find to come up with creative names for these companies that
That's a
people
good
hadn't
piece
used
of
before.
trivia. That's a good
Yeah,
piece of trivia. I've been trying to use video, like N64 video game inspiration, but that's
yeah, but see,
every
you need to have a theme. You have to
yeah,
have a theme.
yeah, I like that.
Yeah, so Quaise is a place on Nantucket Island. Quidnet, Altarock, Greatpoint. Yeah,
Cool.
and so yeah, in the case of Quidnet, the early non-dilutive funding came from Halliburton. We actually put together a partnership with Halliburton to test the technology in the field, and Halliburton absorbed the budget to do some of the subsurface work. So that was a different approach, not a federal agency, but in that case, it was strategic non-dilutive funding.
Hmm. And so that's like one of the first steps you take, apart from evaluating the opportunity and looking at the commercialization pathway and work figuring out where the risks are and how you're going to mitigate them. But the first kind of step that you take is to more or less try to access some non-dilutive funding.
Sometimes, I mean, in the case of a lot of these very deep science, energy or water technologies, that's often a really good place to start just because the risk profile is different. It's also not something that most mainstream venture capitalists are set up to take. So it's oftentimes really good if you can take that very first step of getting it out of the lab and into more of a, so it's sort of out of the lab and into the lab, out of basic research into basic research and development towards commercialization. So if you can take that first step, it's a really good start towards raising more money from either venture capitalists or angel investors or strategics.
And this difference between basic research and basic R&D towards commercialization, what kind of quantifies that for you, the difference, so to speak?
That's a really good question. I don't
Like, presumably there's a direction in the ladder, right? Is that it's like a vector that makes the difference?
Yeah, I mean, I would say I don't know if it's quantifies, but I would say that one of the really key metrics for me is whether or not um, there's enough there to convince really experienced developers, innovators, people that come out of the industry and know how to build the thing that you're trying to build. That's a big metric for me because what I try and do is know what I know and know what I don't know. And so, for example, when it comes to building a directed energy drilling rig, that's obviously not something I know how to do. But Carlos Araque, from the engine, spent the majority of his career at Schlumberger. And it's exactly what he did and what he does. And he surrounded himself by a team that can build that type of a system. And so, convincing him and having him walk through the science and see that the basics are there for something that can scale is a big step. I don't know if there's another way to really quantify it because every technology is a little bit different. But I think you have to have enough there to make the basic, to get to basic assumptions around competitive economics. You have to be able to at least have enough data there to conceptualize the product, conceptualize the design, and have a place to start on comparing what the cost would be to the next best alternative.
And getting
So
that data
yeah.
is really more about consulting with experts than anybody else. Like, even in the Quidnet example, you decided, okay, we need to assess this somehow. We need to speak with a company like Halliburton in order to figure out what's in use, what the economics are, what the costs are, and how we are, what our value proposition is with respect to that, right?
Yeah, in the case of Quidnet, it was a combination of both talking to industry experts like Halliburton, but also doing our own internal cost estimation. So there was a good couple of years that I spent really just with the founding inventor, whose name is Howard Schmidt, just going back and forth on the design cost, and then getting estimates and evaluating the risk with other experts in the field.
With other experts. And so when you look back, because I know you've done this, I mean, this is more or less your career, right? So I'm just curious, some of the mistakes you might have made earlier with the first one or two of these that you've done. What did you do different? What did you do then that you're now doing differently?
That's a good question. That's the $1 million question. I think one of the biggest challenges is timing. Market timing is everything. So, I mean, you can find a lot of really exciting technologies, exciting science, exciting innovation, but it all comes down to whether or not the timing is right for that particular invention and that particular market. So I would say if there's any one mistake that I think that I've made several times, it's misunderstanding or misrepresenting the time, the time to get the product into the right market. And I mean, and at the end of the day, that's what entrepreneurs do really well. I mean, that's where the magic is. It's not that these technologies don't exist. They're, just like in the case of Quaise, the technology was in the lab at MIT. It was there for almost a decade, I think.
Right.
Since he first started. So it's not that it doesn't exist, it's that you have to find the right time to extract. And you can't be too early and you can't be too late. So that's probably the biggest mistake, and companies have failed because they don't get the right timing, because either you require a lot more capital than you expected, or you just can't get there. So that's I think that what I have tried to do more recently is take a harder look, or a more honest look, about where the market is. But it's a very difficult thing to predict. I mean, climate science, climate change. I mean, even when you talk to the experts, they have a difficult time predicting what's going to happen with climate change. So, with water, for example, it's a very difficult thing to determine. Are we a year from a major water shortage? Are we 10 years? Are we 25 years? It's hard to know.
What do you personally think?
It's a good question. I don't like to. I don't want to be sort of.
We saw it with Cape Town a couple of years ago, right? Or even a year ago. They basically ran out of water. I would consider that a major event.
I think at the end of the day, that's the writing on the wall. Is you start to have cities that are, even though Cape Town found a way to, get around getting to, I guess, day zero, they called it.
Well, then it rained. I mean, they got lucky, right? I think that.
And that's exactly the point. Is if your water policy revolves around praying for rain and getting lucky, there's something fundamentally wrong. And the same thing happened in California. California had the worst drought in over 100 years, and then it rained.
Yeah.
And they had several years where there was tons of rain, and it was out of sight, out of mind. And now people don't even remember the severe drought in California, and nothing's changed. We haven't invested in the basic technology. We haven't changed the policy. We're still pumping groundwater out of control. The state now has a plan to regulate groundwater, but it's going to take 20 years to implement it. Yeah. And they may get caught with their pants down.
And do you believe that innovation can save the day, or it's a mix of everything, right? Like there are people out there that would say that we have all the technologies that we need in order to avert climate disaster. And you're at the complete other end of the spectrum, working, at the cutting edge of innovation.
Yeah, I don't know. I don't think it's that innovation can save the day, because I'm a big believer in that technology only matters to the extent that it really enables a new service, a new tool, a new capability for humanity. So it's not just as simple as saying the technology is there. You have to really figure out how that empowers either a person or a business to do something very different. And so when I look at like water, for example, I think maybe what's different about the way I see things is that I see desalination as this like incredible tool. Like if we could harness desalination, we could literally eliminate water scarcity as a resource constraint. We could do what Israel has done, which is go from, you know, water scarce to water abundant to the point where water is not a constraint. It's not a limiting factor. And so I think that the people or the cities or the companies that realize that first and embrace developing the technologies to get desalination truly to mass market scale are going to be incredibly empowered. But most people look at it the opposite way. Most people see desalination as kind of like this burden, this thing we have to do. It's too expensive. It's got all these environmental issues. So they're pushing it away instead of saying, well, where would we need to get desalination for it to actually be an incredible tool? And so I don't know. I think it's a situation where the technology is there. It exists. It's in the lab right now, but people haven't put the willpower into turning that into real tools.
And so what do you think is necessary? I mean, what is the world missing right now? A way to do that?
Well, that's a good question. I think part of what's missing is the motivation. I think it's just a function of being motivated. I think in a lot of ways, in the United States, we're very fortunate that we are wealthy enough to kind of ride it out on climate change, but that's not the case in other parts of the world. Even in countries like China, there's a lot of problems there that they can't wait out, that are creating major health issues, major water quality issues, and they have the willpower and are aggressively investing in these technologies. And I've seen a lot of technology that had a lot of promise get swept up and moved over to China just because they have no choice. So I think that's a big part of what's missing is a willingness to really, roll up our sleeves and build the infrastructure. And China's doing a lot of that. And they're doing it not just in China, but they're doing it all over the world. You go to a lot of places and it's the Chinese that are developing the technology, building the infrastructure, and developing the kind of next generation of tools. So that's one big part that's missing. The other part, just from the startup ecosystem, is I think we're still not at critical mass in terms of the investor community. So I think when you look at other areas of technology, there's a very robust investment ecosystem, all the way, from early stage tinkering all the way up to very large, billion-dollar venture capital deals to get companies to critical mass. I think that's really missing on things like energy and water technology. But it's changing. It's getting there. Every day there's a new group or a new venture fund popping up. So I think it's changing, but it is slow.
And you firmly believe that there are these game-changing innovations in the lab already, and it's just about people coming and extracting them.
Yeah, no, they're definitely there. And honestly, it's about I think it's about attracting entrepreneurs, because entrepreneurs are the ones that bring the magic. They're the ones that connect the market, the product, and the science. And so it's really important to have entrepreneurs be excited and motivated to really go in the lab, get these technologies, turn them into companies, and build businesses. I think if the entrepreneurial energy is there, I think it'll happen very quickly.
And so what if you were speaking to a young entrepreneur that wanted to do something like this, what type of advice would you give him? And the first thing that comes to mind.
That's a very good question.
Or even you can think about it, because you are that entrepreneur, you were that entrepreneur, right? So what would you tell yourself?
Yeah, I'm trying to think what advice I would give myself back in the days. When I started out, we were just roaming the halls of MIT and Harvard and any other university, trying to find things that we thought made sense and made for big picture solutions. So a big part of my focus has always been on simplicity and trying to find things that you can very quickly understand why it's a solution that matters and a solution that makes sense. So I don't know, I think I would encourage entrepreneurs to try and think big, because I think that's maybe one of the things that there's this in the energy and water space. There's kind of this gravitational pull towards being conservative, because that's the nature of the beast. That's the nature of the industry. You're dealing with utilities, you're dealing with, you know, slow moving, very conservative energy companies. But at the end of the day, I don't think the dynamics around innovation are any different in energy and water than they are in any other sector of major innovation, from drug development, telecommunications, the computing industry. The magnitude of the idea is what drives the magnitude of the excitement and the magnitude of the impact. So I don't think, you know, thinking smaller helps. I think you need to think big. You need to think in terms of big picture problems and solutions that ultimately are very simple in retrospect. They're very complicated when you're developing them, but in retrospect, they're remarkably simple. And I think that that's what makes for the most exciting technology. The technologies that create tremendously simple solutions are the ones that are most powerful.
Great answer. And so I want to switch gears just a little bit to some more practical advice, actually, on funding and things like that. Both DOE, ARPA-E, SBIR, whatever. Are there best practices that you have, and any kind of high level advice that you would recommend to people that go after funding like that?
Put together good teams.
Team is everything.
Teams are a big part of it, and I think federal agencies, like anybody else, want to invest in technologies they feel like are going to have legs at the end of the day. So they want to feel like that, you know, their funding catalyzes industry funding, catalyzes private funding. So for the most part, what I've tried to do is put forward really great teams that combine, you know, best in class researchers with best in class partners and investors that can carry the technology once it's been proven through, you know, TRL 3 or 4. Because I think, yeah, that's what usually leads to good funding arrangements.
Okay. And what about raising from private investors, VCs, or rather even going after strategics? Any advice there? I mean, it's a bit of a different beast, obviously, right?
Yeah, it's a different beast. I mean, venture capital, I guess the thing that I've learned is venture capital has a time and a place. So you got to be a little bit careful about when you take it and how you take it. I think it's fantastic. It's again, it all comes down to timing. If the timing is right, venture capital is absolutely the best way to scale a business quickly. And you have to do it when scaling the business quickly is what's going to matter. If you do it at the wrong time, it can have a dark side. Which is, you know, losing all of your equity and having, you know, the investors take over the company or go in a different direction with the company, or flat out, you know, kick the founders out. So you got to be very careful when you take it. So, and actually one of the things that I've noticed is I think is a lot of younger entrepreneurs are being extremely thoughtful about whether or not to take venture capital and build the business early days without it. And I think that's one of the things that's really improved in this space. When I think back to like clean tech 1.0, I think entrepreneurs are very thoughtful now about other sources of funding, getting creative about bootstrapping, getting creative about early revenue, finding ways to just kind of stay alive long enough to get technologies into the market before raising venture capital.
Even in deeper technology.
Yeah, even in deeper technology. Yeah.
Yeah. Yeah. There's, you know, there are some companies, I think like Desktop Metal, for instance, is one that I've tracked, where they embrace this sort of pre-order way of doing business. So they had customers that were literally paying them to build the product that they were delivering. I don't know if you've seen that. I guess that's even like the way Tesla, you know, sold roadsters to people in order to fund the building of roadsters or whatever.
Absolutely. No, and I know Rick Fulop, the CEO and founder of Desktop Metal, very well. I've known him for ages. He's an extremely talented entrepreneur. And yeah, I mean, and that's exactly what he does well, is finding a path to, well, actually, and I would say Rick is a great example of someone that has the capacity to both get really creative about having customers, fund product development, and also raise an enormous amount of venture capital. So he does both very well, and that's what he did with Desktop Metal, which propelled them now into the public markets.
Yeah,
But
very
yeah, I mean,
exciting.
the Tesla Roadster is a perfect example, right? The Tesla Roadster was a very expensive, two-seater sports car, and it wasn't even their technology or their design, but it was a way to get started. It demonstrated the basic, concept, and they found product market fit to get to the next stage. And develop, an expensive but proprietary, sedan. So yeah, it's a great analogy. But you have to find the Roadster to start with.
And just as an aside, actually, the concept of product market fit is interesting, especially with these hard science and sort of deeper tech ventures. I mean, when do there's a lot of literature out there of how you define product market fit and when you reach it, or how and with software platforms, it's like, or marketplaces, even apparently you feel it, right? When you're doing so many customer service tickets that, you're completely overwhelmed, and your full-time customer service, you've kind of reached product market fit, or different sort of indicators like that. I mean, what do you think it is? And I guess it might be different for every company you've been involved in, but is there something tying these things together at all? How when you've reached product market fit? It might be that
Yeah,
a
it's funny.
customer, yeah.
I went through Y-Combinator. Let's see, it was in summer 2017. I went through Y-Combinator, the
Why did you do
famous
that?
tech. How or why?
No, why? I'm curious. I mean, you were already an established investor and entrepreneur at that point. I mean, it was just so that you could kind of further your education in a different way, or?
Yeah, I did it for a couple of reasons. Even though, as an entrepreneur that had already started a bunch of companies and raised money, it in some ways felt like a step back. But it was the first time Y Combinator had ever released a request for water startups, and so I thought it was a really good opportunity to kind of get a very different perspective from investors that are not in the water space, not in the energy or clean tech space, and just have built successful businesses. And so I valued that. I really wanted to hear how just mainstream, very successful tech investors thought about it and looked at building a company in the water space. And actually, I learned something really interesting, which is related to your question, because I thought going through Y Combinator, I would immediately have this issue with building infrastructure and how do you actually scale that efficiently. And I thought Y Combinator would be all about just scaling quickly, scaling massively, just find a way to scale. And actually the advice they gave me was exactly the opposite. They literally said, just find one customer that loves the one thing that you're doing, and it doesn't even matter if it scales. And I actually think that is probably the best possible advice around product market fit, is all you have to do is find one customer that loves the one thing that you're doing. And once you have that, you can figure out how to build from there. But that's the part I think that is most difficult to do. And that's where the rubber hits the road, is can you build something that works, that really delights a particular customer or market? And I think when you start to think about it that way, it does a lot of things that maybe you don't even realize. It immediately simplifies the technology. It immediately puts you on a specific track where maybe you're extracting certain traits about the technology, but you're leaving all the rest and all the other complicated stuff behind. And I would say that in a lot of my companies, that's probably the most important exercise, is boiling it down to that one most simple, most basic, MVP that you can get out there, and show that it works for the customer. And from there, you can do anything. If you solve that, you're 75% of the way there.
Yeah, and in terms of forming an operating commercialized company, right? I mean, there's obviously
Yeah.
a ton of other hurdles, but as far as extracting and building an actual company with interest from customers and that's on a path to commercialization, that is where you got to get to, is getting that one
Exactly.
MVP out.
And I mean, I'll give you an example, like as it relates to, Quaise, which is developing the deep drilling technology. It's going to be a long time before we're drilling a 10-mile hole in the ground, at, 500 degrees C and extremely high pressures. And so in the early days, one of the things that I spent a lot of time on is trying to figure out, okay, well, how do we really simplify this and find, the earliest application of directed energy that doesn't require, ultra high temperatures, doesn't require high pressure, doesn't require going super deep. Maybe it doesn't even require going vertical. Maybe we're just drilling a very short horizontal hole. Maybe it's for, boring company tunnels or utility applications or mining applications. But start with just something that you can build and get working before layering on all the other things that get you to the grand vision. And that's, yeah.
So what did you guys do?
So so we narrowed down to a couple of market applications. One of them was boring horizontal tunnels for like water and utilities. So that's that's one of the early applications that's going to be tested. In fact, one of the first demonstrations that the company is going to do is going to be a long horizontal hole. And then the other one we explored, but never really came to fruition, was boring tunnels for transportation. We actually had some discussions with the boring company to figure out whether or not there was a distinct advantage, using this approach. For example, with traditional, they're called tunnel boring machines. They use a rotary bit that kind of grinds away at the rock. It creates a lot of vibration. And so what we had talked to them about is whether or not using directed energy could actually not only speed up the process, but eliminate a lot of that vibration, and also create a situation where the energy is being used to soften the rock substantially, so that if you're going through harder rock or harder geology, you don't wear out the bit as fast.
Cool.
So, it's just it's an iterative process.
Yeah, like everything. A couple quick questions that I have. Working with the professor or the inventor, as far as the company spins out, and there's a couple schools of thought on this. I just wonder where you stand. Involving them as a CTO. Do they stop working at the university? Can you speak a little bit about that?
My preference is actually always to have the founding scientist or founding inventor involved as much as possible. I don't think it's always the best fit. I don't know, I would say it's maybe 50-50 in terms of the founding scientist actually joining the company full-time versus staying, in academic research. But I have had the privilege of working with a number of founding scientists that are extremely hands-on and very practical. And those are the kinds that I think make for very good CTOs or CSOs. But I've also started companies where the best role is for the founding inventor to stay at the university, be chief scientific advisor, and to build more of a commercially oriented team outside the university. So I don't think there's any rule of thumb there. It really depends on the person.
And what about working with TTOs? I mean, where can you speak a little bit about people have different experiences. It's a difficult topic. What are your thoughts and experiences, and how would you improve them maybe?
Yeah, that's an interesting question. It's been a little bit all over the map for me. I've had some incredible experiences. I actually think MIT is a great example of a technology licensing office that is extremely founder friendly, commercialization friendly. I mean, their goal really is to get technologies out the door. So they have a very good process for working with founders and entrepreneurs, and being flexible and understanding the process of raising capital and the fact that it takes time. Other universities, I mean, I'm not going to mention any names, but I have had some not so great experiences, and it's usually around the university holding on a little too tight. You have to be willing, you have to be willing to trust other people. Universities aren't in the business of scaling technology and scaling products. And so you have to be willing to let go a little bit. It's like raising children. At some point you gotta let them, fail a little bit and learn on their own, and you got to get them out there. So the bad experiences I've had have been where TLOs just want to take or play, maybe, I don't know if it's play too much of a role, but not play the right role. Not just say, listen, we're in the business of licensing the intellectual property. Let's let the experts and the entrepreneurs and the investors do what they do best. And yeah, so there've been a couple instances where it's fallen apart when the university sort of wants to play entrepreneur.
And is there an ideal mix for them on the cap table? Like, is there a target that you have in mind? And how they're involved, like in an ideal sense?
I wouldn't say there's a boilerplate. No.
Every negotiation is completely unique and different.
Every negotiation is completely different. It depends also on what the nature of the intellectual property is. Have they fully patented the product, or just one aspect of the product, or just one piece of intellectual property that has to go into the product? So it depends on how broad the intellectual property is, and how many other pieces are going to have to be pulled together. But no, it's not uncommon for universities to want to have an equity stake, and I think that's great. I think it helps to actually align incentives when the university, a big part of their return is actually coming from equity and not just on milestone payments.
Right.
So I actually think that's a good thing. If you can use equity as a way to alleviate the burden of annual payments or milestone payments, I think that's a good thing, and investors like it too.
You prefer equity over these milestone payments?
Maybe not 100% equity. I actually prefer to have a little bit of a balance, because you also don't want to take too much equity away from founders. VCs. The problem with VCs is they always have a hard and fast number where they want to be,
right,
on equity ownership. And so if the university ownership will often eat into founder ownership, not investor ownership.
Right. And royalty, just while we're on the subject, how do you feel about royalties, sale royalties, I guess?
Depends on the product.
Depends on the product.
I've actually, what I've tried to do is sort of kick the can down the road a little bit on that until you know enough about what your business, because oftentimes you may know what the product is going to be, but you don't really know what the business, the real business model is going to be.
Right.
And so it's hard to sign up for royalties when you don't really know what you're selling or what your profit margin is. So sometimes it's better just to kick the can down the road, either put an option agreement in place before you get to a full-on license, and it gives you a little bit more time to figure out the business model.
Great. And patents, critical, got to go after them. TTO can do it for you. I mean, can you just speak a little bit about how you view patents and their importance and best practices with that?
Patents are, yeah, they're definitely important. Now, they're not everything, but it definitely goes a long way to putting an early stage package together. I mean, venture capital investors, or any investor really, wants to see that you have a defensible position. And as soon as you demonstrate something of value, there's inevitably a whole bunch of people that jump into the space, including big companies with enormous resources. So for example, if Quaise is able to demonstrate that you can use, energy to drill, and that's going to be extraordinarily profitable, then there's going to be a whole bunch of people, from Schlumberger to Halliburton to oil majors, jumping into this space. So you have to have something to beat them back with a little bit. So I think patents are important. They're not always, the value of a patent always comes down to your ability to actually defend the claims in court. And so you really have to, you have to be aware of that. You have to first have strong claims and be aware of what they cover and what they don't, and you have to be willing to defend them. Otherwise, it's not worth very much. And the problem with patents these days is it's hard to defend them in places like China. And China is such an important part of the global economy now that's where a lot of technology is going or coming from. So,
right.
for example, and actually it's a relevant example, but in the case of Quaise, there was a Chinese group that actually came to MIT and spent a whole bunch of time with the inventor, learning as much as they could, and then they went back to China and reproduced the lab experiments. And I don't think they do it like maliciously. It's really just part of their culture. That's how they learn, and that's how they get technology on the ground in China. And so it's very common for that type of thing to happen, where they learn as much as they can, they read the papers, they analyze the data, and then they go build it.
Hmm. So are you concerned about a Quaise clone popping up in China anytime soon?
Yeah, I am
Yeah.
actually.
Okay.
I do think it's an inevitability. I hope that we at least have a head start, and I hope that that lead accelerates, because we have the people that have the vision for where it needs to go and how to put all the pieces together. But yeah, no, it's definitely a concern, and it will definitely become a much bigger concern as the company gets close to market. You know, when money starts coming in and there are products in the field, that will become an issue. But
Cool.
and you know, coming back to your question, that's why you have to work with MIT or whoever is the licensing office to strengthen the intellectual property as much as possible, because in most situations, the university retains the right to prosecute the IP. So it's really up to them as to what is filed, what's expanded on, what countries are covered. So yeah, you have to have a really good working relationship with the TLO.
Okay. All right. Good advice. Any other things you want to share on this topic, or any other pieces of advice for the young entrepreneurs and researchers out there looking to make a difference?
I think it's great timing. I'm really excited about some of the things that are coming out of the woodwork these days, and I've been spending a lot more time with younger entrepreneurs. It's fun to see their energy, because it reminds me of when I started out, because you kind of like, you know, don't know enough to know what the issues are, so you just go in, you know, full steam ahead. But it's great, because that's why, you know, that's why younger entrepreneurs create the future, because they're the ones that have the energy to go out there and do it. So I don't know, I actually think it's really good time for a lot of things in the energy, water, general climate tech space. I think a lot is changing. I think it's changing faster and faster every year. And I think a lot of big companies, like if you look at what's going on in the oil and gas sector right now, they've had like this epiphany all of a sudden that geothermal could be a great use of decades of technology and expertise that they've built up, because oil and gas prices are so low. So now you have like this, you know, cadre of oil and gas guys peeling off to start geothermal companies. And yeah, I mean, that's what you need.
It's great for your space. I mean,
It's great.
you view that, yeah. Well, and
I mean,
I think
geothermal is like this, yeah, it's like this renewable that nobody ever talks about. It doesn't even get mentioned when people talk about renewables. And yet I think it's going to be hugely critical for energy going forward.
yeah, you know, like a true entrepreneur, you're both optimistic and hopefully right when everybody else has been wrong for all these years. So I guess that's the way
We'll see. We'll
yeah.
see. I don't know. I've been working on geothermal for a long time,
Yeah.
all the way back to when MIT first published their report in 2008. So it's yeah, it's been a long time, and that's, you know, back to the question on market timing. That's the problem. Is, you know, you think you're 2 years away, but you're really 20.
Yeah, that's crazy.
Got to stick with it long enough.
Timing is everything. All right. Well, Aaron, I really appreciate the time today. Is there a place that you prefer for people to be able to kind of find you on Twitter, or what do you like these days?
That's a good question. Yeah, I am on Twitter. I am on LinkedIn. I don't know. I'm actually looking for a new platform. I think there needs to be a new platform. I'm still building a website, so it's not up and running yet. But
okay, so people can find you on Twitter and LinkedIn.
I thought you're building a platform. That's
yeah.
That's where I should be.
Soon enough. So we're hoping to release Bountiful soon enough. That's part of this Out of the Lab podcast, is to try to add value to some of our early users that are waiting on the wait list. But slow and steady, timing is everything. But hopefully hopefully soon we're launching. So yeah, Aaron, thank you so much for joining us today. I think you're our first out of the lab guest, and we hope there are many more to come, and we hope to see some really exciting progress in water and geothermal at your hand and at others.
We shall see. We shall see. Yeah, thanks for having me. It's been great.
Thank you so much, Aaron. Please, everyone, visit Out of the Lab. You can find us on Spotify, Apple Podcasts, and Google Podcasts, anywhere where you get your podcasts. And you can visit bountiful.work to sign up and join our community. Thanks very much, Aaron. Have a great one.
Appreciate it.
Thanks for listening. But now we need your help. We're building a community of scientists, students, entrepreneurs, industry leaders, and investors to commercialize meaningful technology and research. Join us at bountiful.work today to find opportunities and realize your power to save the world.